Welcome viewers, in this video we will see the AC through a capacitance only. When the AC voltage is applied to the capacitance, what is the behavior of the circuit, what is the behavior of voltage, current, and what is the expression for instantaneous power and average power, we will see in this video. Now consider the capacitor is given with the AC voltage V of t equal to Vm sin omega t. The alternating voltage is applied to the capacitor. This I of t is the instantaneous current flowing through the capacitor. I will refer the waveform. This is the supply voltage V of t. V of t is applied. It starts at 0 degree. The maximum value is Vm. Is referred by V of t. V of t equal to Vm sin omega t. In capacitor, the current is leading by 90 degree. Current will start before the starting of voltage. Before starting the voltage, current starts 90 degree. Before that, it means the current is leading the voltage by 90 degree. So current start from here. Before starting the voltage, the current started at an angle of 90 degree. So this is the current waveform I of t. This is the maximum value Im. So the current is leading the supply voltage by 90 degree in the capacitor volt. When the capacitor. Now we will see that how it is. We will see through the equation. By analyzing the voltage and current equation, we will analyze what is how it is, how the capacitor current is leading by voltage by 90 degree. We will see the equation so that we will come to know how this leading is happen. Now consider the supply voltage. The applied alternating voltage V equal to Vm sin omega t. So this is the supply voltage. We take this equation number 1. The instantaneous value of current in the circuit at the time t is given by I equal to dq by dt. Because of capacitor is connected, the I equal to dq divided by dt, rate of change of charge. But we know that Q equal to Cv. We can replace Q equal to Cv. Right? So I equal to d by dt of Q is replaced by Cv. Now C is taken outside. So I equal to C dV by dt. Now I equal to C into d by dt of this V is replaced by the first equation Vm sin omega t. The V is substituted as Vm sin omega t. So I equal to C, this Vm is constant, so we taken outside. So differentiation of sin omega t is cos omega t into omega. So that I equal to omega into C into Vm, omega C Vm into cos omega t. So this omega C is brought to the denominator. So 1 divided by omega C. So omega C, 1 divided by omega C, both are equal. So this 1 divided by omega C is nothing but Xc, that is a capacitive reactance, which is very similar to the resistance, opposing the flow of current, is very equal to the resistor value. So 1 divided by omega C is replaced by Xc. Now I equal to Vm by Xc into cos omega t. Xc is nothing but capacitive reactance, that is 1 divided by omega C. Now Vm by Xc can be written as Im. I equal to V by R. Here V by Xc. Voltage by capacitive reactance is equal to current. Very similar to I equal to V by R. So I equal to Im cos omega t. So this cos omega t can be written as sin omega t plus pi by 2. In order to compare equation 1 and 2, the cos is now changed into sin omega t plus pi by 2. That is I equal to Im sin omega t plus pi by 2. So that is I equal to Im sin omega t plus pi by 2. We will take it as equation number 2. Now we got the equation for current. What is the first equation? V of t equal to Vm sin omega t. This is the equation 1. So applied voltage. Now compare these two equation 1 and 2. What is the sin value? Here sin omega t, here sin omega t plus pi by 2. That is current is leading the voltage by 90 degree, pi by 2 degree. In case of inductor, it is minus pi by 2. Minus pi by 2 means lagging the voltage by 90 degree. Here plus pi by 2 is there. So by comparing equation 1 and 2, there is a phase difference of pi by 2 or 90 degree between voltage and current. So that it shows that the current is lead the apply voltage by pi by 2 or 90 degree. So that is the waveform we already discussed. The current starts before the voltage starts by 90 degree. So now by equation we are clearly identified that current is leading the voltage by 90 degree. Now we'll go for the instantaneous power. Instantaneous power means at a given time. P equal to V of t into I of t. V of t is Vm sin omega t. This is equation 1. I of t is Im sin omega t plus pi by 2. This is equation number 2. So Vm into Im sin omega t. This sin omega t plus pi by 2 can be written as cos omega t. So this sin omega t into cos omega t can be written as cos 2 omega t divided by 2 based on this formula. Cos 2 omega t equal to 2 into sin omega t cos omega t. Bring these 2 in the denominator. So cos 2 omega t divided by 2 is equal to sin omega t into cos omega t. So this sin omega t into cos omega t is replaced by this parameter cos 2 omega t divided by 2. So by rewriting P equal to Vm Im divided by 2 cos 2 omega t. So this is the instantaneous power. From this we can find the average power. We can calculate the average power. Average power equal to average means we need to integrate for a entire time period. So that we will get average. 1 divided by t 0 to t p into dt. What is the time period? Pi. Half cycle. 1 divided by pi 0 to pi. Then the instantaneous power is available here. Vm Im by 2 cos 2 omega t into dt. So Vm Im by 2 is taken outside. So that Vm Im divided by 2 pi cos 2 omega t is sin 2 omega t divided by 2. Integral sin cos 2 omega t is sin 2 omega t divided by 2 with the limit 0 to pi. Now we'll substitute the limit. So that Vm Im divided by 2 pi is substitute this limit sin 2 pi divided by 2 by substitute the lower limit. So minus sin 0 by 2. So the sin 2 pi value is 0, sin 0 also 0. So totally the power is 0. The average power in the capacitive circuit while applying AC voltage is 0. So in this video we discuss about what is the behavior of current and voltage when AC voltage is applied to the capacitor. We identify that current is leading by 90 degree. We analyze the two equation. From current and voltage equation we identify that current is lead by 90 degree. Also we calculated the expression for instantaneous power and average power. Thank you.